Hi guys. A month ago, I came across this fascinating Python library called FastF1. It's basically a library that gives you access to F1 timing data. It contains car telemetry data, even the tire data, the weather data, the event schedule, and session results of multiple years and multiple session types. So I was like, this is a quite interesting library. I should like make something out of it, and I did. So here's my F1 dashboard that I created on it. So I'll be walking you through what I built in this F1 dashboard. First, we'll start with basically built on Streamlit, which is a user interface Python library. It contains over 6 years of historical data. You can select any year you want. And according to the year, the circuit also dynamically changes because every race didn't have the same circuit. So let's go like we'll select 2024 and we can select 2021. It's my favorite season. And the final race, which was on Yas Island in Abu Dhabi. Select the session type as race and we'll pick our driver as Lewis Hamilton. What we do is if you click on the show analysis button, it gives you data. You select the driver or the circuit, it dynamically gets you the image of the driver and the circuit as well. So here's the a pic of Hamilton and here's the Yas Island circuit. So now I divided my project into two types, which was a full race analysis, which was totally focused on data analysis, and and the other is a machine learning pace predictor. So I tried it. So I tried to do machine learning as well. So let's talk about the full race analysis first. So it gives you full analysis, like the finishing position of Hamilton was P2. His fastest lap was of 1 minute 26, and he finished the race, and he was driving for Mercedes. Now here's some insights like his fastest lap was lap 43 with a time of 1 minute 26 on hard tires. The average speed during that lap was 279.2 kilometers per hour. His longest stint was 43 laps on hard tires. The dashboard also gives you some sector insights, like in which in the three sectors, which was his best time. There was some really stats on Earth, like total how much he drove, how much time did he drive for, what is the total distance covered per lap, how many average gear shifts were done per lap, what was his top speed, like his top speed was 319 kilometers per hour. Now DRS was used on two laps, and his most impressive sector was sector 1 on lap 43, which was of 17.6 seconds. Now I'll be talking about some graphs that I built, like the tire strategy graph. It basically gives you the stint length and what type of tire did he use for the whole race, entirety of the race. His first stint was from lap 1 to lap 14, which was on compound medium. So he was using medium tires on that. And his stint 2 was from lap 15 to lap 58, which was till the end of the race, which was on hard tires. Now, like I extracted the fastest lap from his race, and this was the telemetry analysis on it. This is a graph that shows how his speed was varying from lower to. It's basically like if the speed was increasing and here it started lowering down, means he was braking and he was at a corner or something. So this was the speed trace. And there are four more graphs which gives the throttle application, like where he was using his throttle, where were the braking points. Basically, braking points mean where he was around a turn in the map in the circuit, his rotations per minute engine, and his gear shifts, like how often was he shifting gears and that. This was my race analysis part. So this was my full race analysis. So the next part was like I was like this was not enough for a good project. So I thought let's try machine learning as well. So the next part was I created a machine learning pace predictor which predicts lap times of different laps. You can choose different tires in that, different tire age. You can choose which stint was, and you can even change the weather scenario because the fast F1 library gives you weather data as well. So what happened was I started with the machine learning part. I gave the data. I used two models, XGBoost and LightGBM, to predict lap times. So I gave my data to it, and it was giving me an accuracy of, it was basically overfitting. The machine learning model was not predicting correctly. So what I had to do was uh, I had to train a model for each event that happened. Like if it was the Suzuka circuit, I had to predict. I trained a different machine learning model for Suzuka, and I trained a different machine learning model for Yas Island. So now the machine learning pace predictor does is like when once you have selected the race details, it also selects which machine learning model will you be using. So here you can select the lap number. I trained the machine learning models before showing you the walkthrough of the machine learning models. I trained the machine learning models and I got an RMSE score of 0.91 seconds and an R square score of 86%. Now, 0.91 second means that it predicts lap times within the error of 0.91 seconds, and it has an 86% accuracy. So let's walk through the machine learning user interface. So here you can select your lap number. For example, like I'll choose lap number 12, and we can say like the tire age is also 12 because we'll be using stint as stint 1. It's this first stint, and you can select different type of tire compounds, which tire compound he was using and which compound was he not using. Like I'll go with, let's make it more fun. We'll go with soft tires because medium and hard you already used in the race. And you can even simulate weather. You can use the historical average, which means what was the weather at that time. Or you can simulate sunny and hot, cloudy and cool, or light rain. We'll go with light rain. And then we can predict lap time. So the machine learning will predict, and it has given us a lap time of 1 minute 29 seconds, 0.412 milliseconds. Now, in a full race analysis, his fastest lap was 1 minute 26 seconds, which is still, it is now the lap predicts 3 seconds more than that. Now, the most exciting part of this project was like I wanted to add generative AI to it, and I didn't understand how to add that. So what I thought was of using Google Gemini. You can use your Google Gemini key. You have to just enter your key here, and you have to save your key. I am a developer, so now my API key is valid and it has used my API key. Now here's a button that uses, basically it makes Google Gemini. So basically what the generative AI part of the project does is it basically converts Google Gemini into an F1 commentator, which gives you an F1 commentary on the labs that you have selected and the conditions you have selected for that lab. When you click on get the pundit's verdict, the Google Gemini API key is called and gives you a F1 race commentary for that lap which you have selected in the lap time predictor. Right now it's loading, it's waking up the AI commentator. Now, Google Gemini is an F1 TV commentator. Now it gives you a full talk about what is happening on that track and how is performing. Let's see. Now the what Google Gemini told us was, all right, buckle up F1 fanatics, because we have just witnessed a fascinating glimpse into the simulation chambers, and let me tell you, it's got Lewis Hamilton's masterclass written all over it. Picture this. Yas Island, lap 12, and the skies are starting to weep a little. We are talking light rain. Now add to that the fact that Lewis is out there on a 12-volt lap old soft tires. Yes, you heard me right. The softest compound, already past its prime, now trying to find grip on a damp track. Most drivers would be tiptoeing, practically parking it, but not Lewis. The simulator predicts a lap time of 1 minute 29 seconds. Now, on paper, that might not sound like a blistering Yas Marina pole lap, but let's put it into context, shall we? With those worn out softs practically dancing on ice and the track turning into slippery side, that 129,412 is not nothing short of incredible. It's a testament to his uncanny ability to feel for grip where there simply isn't any. Balancing the car on the absolute ragged edge, what a phenomenal demonstration of precision and car control under the most challenging of simulated conditions. Truly remarkable. So basically, this was Google Gemini acting as an F1 TV commentator. I have Now this was my entire project, data gathering, which includes data gathering from fast F1 library. It includes data analysis, data visualization, machine learning prediction, and even generative AI. I have deployed this project on Streamlit Community Cloud, and if you want to check it out for yourself, the link for the website is in my GitHub link, which will be down in the description where you can check it out. Make sure one thing that you carry your own Gemini API key, because I won't be giving you any free Gemini API key. So this was my project. Thank you.